Complementary angle theorem. What is complementary? So let's say two numbers are complementary. So let's say we have x and y. They are complementary. So that means x plus y equals to a sum. The sum is not going to change. So let's say x plus y is equals to 10. Let's make a very simple example. Let's say there are 10 cupcakes on a plate. Alright. So you and I, we both share these 10 cupcakes. Let's say you eat 2 of them. Whatever you take, I will just take the rest. So these two numbers, they are complementary. You said, alright, I want to eat them all, then there is nothing I can get, right? Alright, you eat them all, then I will just take a 0, so that is equals to 10. If you eat 7 of them, I will just take the rest, so they are complementary. So whatever you grab, I will grab the rest. So our two numbers are complementary. They always add up to a certain sum. So in this complementary angle theorems, like, to be honest, I don't use this a lot in my pre-calculus and calculus classes. But there are 6 formulas that you have to memorize. So what they are saying is you have a right triangle, right? So right triangle means one of the angle is 90 degrees, and then you still have 2 angles left, one in here, one in there. So other than the 90 degrees, the other 2 angles, they must sum up to 90 degrees. So this is a 90, right? The sum of all 3 angles is 180. So you already have 90 degrees. So this angle and this angle, they must sum up to 90 degrees, and they are complementary. So let's say this angle is 30, then this angle must be 60. If this angle is 31, then that angle must be 59. So let's use one of them. So let's take a look at the first one. The sine B is equals to B divided by C, that equals to cosine A. Oh, by the way, what happened in this right triangle? So this right triangle says if you look at if you define your theta, so let's say this is your theta, then this is the opposite, this is adjacent, and then this is hypotenuse. Let's use switch color. So let's say we have a right angle. I call this theta. Then where is my opposite? Is this still my opposite? The answer is no. This is no longer your opposite. If the theta is right over there, then this is your opposite, because the opposite is always facing the theta. And then where is adjacent? Adjacent is a side that is touching the theta, is adjacent to it, which is right next to it. Then this is adjacent. Then this is your hypotenuse. Alright, going back to the formula in the green box, sine angle B is equals to B divided by C. So that is SOH. B is opposite. C is hypotenuse, which is equals to cosine A. So in angle A, we have CAH, right? So CAH, so if A is your theta, then CAH, so adjacent, is sine B, and then hypotenuse is C. So going back to the green box, we have sine B equals to that. So let's say we have sine of 30 degrees equals to cosine of 60 degrees. Oh, I don't need to grab one. So this is right over there. Why they are equal? Let's try to show that they are equal. So what is 30 degrees? 30 degrees is pi over 6. Pi over 6 has a coordinate, root 3 over 2. And then 1/2, 60 degrees is pi over 3. And then the coordinate is 1/2, comma, root 3 divided by 2. What is sine of 30 degrees? Sine is the y coordinate, right? So that is equals to 1/2. And then cosine of 60 degrees, cosine, we take the x coordinate. So 1/2 is equals to 1/2. Alright. The trick is, as long as this angle sum up to 90 degrees, then the formula is true. You don't have to use sine 30 and sine 60. This one you can use sine of 29 degrees. That is equals to cosine of 61 degrees. As long as they add up to 90, you will be okay. So if you use another one, so let's say we use the tangent. Let's say we use this one. I can write a couple equations for you. So this one, you can do tangent. So they have one example right there. So they have tangent 40 equals to cotangent 50. You don't have to follow them. You can do this. So tangent of 10 degree is equals to cotangent of 80 degree. Again, as long as the two numbers are complementary, you will be okay. So as long as they sum up to 90 degree, you will be okay. So you can do tangent of 5 degree equals to cotangent of 85 degree. They sum up to 90, right? You can do this. Tangent of not 0 degree, then you don't have a triangle at all. 1 degree is equals to cotangent 89 degree. 89 plus 1 equals to 90. 85 plus 1 equals to 90. So that's how complementary angle theorem works. Let's take a look at an example. So we have an example right there. I want to find the exact value of each expression. Of course, we do not use a calculator for that. Otherwise, there is no purpose in discussing the complementary angle theorem. So number one, we have sine of 38 degree minus cosine of 52 degree. I am going to use complementary angle theorem, and I want to manipulate the cosine 52. So when I do my thinking, here is what I am thinking. I know that 52 plus 38 is equals to 90, and then sine and cosine, we have one of the formulas for that, right? We have the first one in the green box, sine B cosine A. So I know that cosine 52 is the same as sine of 38 degree, this 38. So we have sine of 38 plus sine of 30 minus sine of 38, not plus, minus sine of 38, so that is equal to 0. Okay, so number two, we have 1 plus tangent square 5 degree minus cosecant square 85 degree. Alright, 1 plus tangent, that sounds very familiar because that is one of the identity that we studied before. So 1 plus tangent square theta is equals to secant square theta, right? So this 1 plus tangent is equals to secant square 5 degree and then minus cosecant square 85 degree. Okay, the 5 and the 85, there must be something that we can do. Oh, by the way, how do I get a 5? If you replace the theta with 5, so tangent square 5, that is equals to secant square 5, right? So the next thing that I am thinking is, well, 5 plus 85 is equals to 90, and then we are looking at secant and cosecant. Where is secant and cosecant? So secant and cosecant, they are right over here. Secant, cosecant, secant B equals to cosecant A. So that is, this is actually equals to cosecant 85 degree. I don't want to miss my square, minus itself. That is equals to 0. Of course, if you use a calculator at the beginning, you will just get a 0. But that beats the purpose of introducing complementary angle theorem, right? Okay, last one. Last one, take a little bit more of work. Number 3, we have secant 35 degree, cosecant 35 degree, minus tangent 35 degree, and then cotangent 55 degree. Alright, cosecant. Cosecant, what can we do for this cosecant, CSC? So cosecant and secant, I can use this one, cosecant and secant. Okay, then now I am thinking 35, right? So I know that 35 plus 55, oh, actually this is a 55. 55 plus 35 is equals to 90. So this is actually equals to secant of 35 degree. And then what about cotangent? Cotangent, look at the formula. Cotangent and tangent, right here. So cotangent 55, I know that 55 plus 35 is equals to 90. So that is equals to tangent of 35 degree. Okay, let's rewrite them. So this one we have secant times secant, right? So secant times a secant, we have a secant square, 35 degree, minus tangent times tangent is tangent square, 35 degree. The reason I picked this is you have to review your Pythagorean identity. So what's that identity? We have 1 plus tangent square equals to secant square. The only difference is I replace theta with 35. So this is equals to, this one is equal to 1 plus tangent square theta, not theta anymore, 35 minus tangent square 35. All right, the tangent and the tangent got cancelled. So the final answer is that is equals to 1. So that would be all for complementary angle theorem. I see you all in the next part.